my name is Carl, and I am part of our group. We are discussing creatine, the compound, and its role in recreational supplementation for bodybuilding, for building lean muscle mass as far as producing energy during workouts. Also later we will discuss ATP's role in medical applications, and we'll also take a deep look into how creatine produces ATP in the body, which is an energy source for bodies during exercise. So in a little bit, we'll also be discussing creatine, and we'll be looking at an entropy balance, we'll be looking at the mass balance, and we'll also be looking at a diffusion rate analysis to determine if creatine really is an effective way of building lean muscle mass and increasing energy during workouts.
I took it 5-6 years ago when I was wrestling in high school. It did give me the energy boost that I needed, but it upset my stomach a lot, so I stopped taking it.
But what exactly is creatine? Creatine is found in foods like beef, chicken, and fish. Creatine is even produced naturally in the body, mainly by the liver. It drives burst muscle contractions by fueling ATP, the energy machines in muscle. ATP are high-energy molecules with 3 strongly bound phosphates. When a phosphate breaks loose, energy is released. Creatine's job is to replenish the phosphates to keep ATP running. Supplemental creatine increases the sheer volume of available fuel to power ATP. Now, let's look inside a muscle fiber to see exactly how this works. Muscle fibers are comprised of many short segments called sarcomeres. Each sarcomere contains contractile proteins called actin and myosin. The signal to contract starts with an impulse from the nervous system. Energy released from ATP powers each cycle of contractions.
Nowadays, pre-workout supplements has creatine in it, so I don't take creatine separately anymore.
Conversion from creatine to ATP is an exothermic reaction, whereas the reaction from ADP to phosphocreatine is an endothermic reaction. Phosphocreatine can anaerobically donate a phosphate group to ADP to form ATP during the first 2 to 7 seconds following an intense muscular effort.
Hi, my name is Farah, and I will be talking about the enthalpy and entropy balances in our system. Entropy is a thermodynamic property that determines the amount of energy available for useful work in the system. In this case, it is a measure of useful work energy produced when phosphocreatine is converted to creatine. This energy produced is used by muscles when they contract. Enthalpy is a measure of the heat in the system, or the change in the heat of the system. In other words, whether the system is releasing or gaining heat. The energy balance refers to the chemical potential of the cells in the muscle. We'll take an in-depth look into these equations and also look at Gibbs free energy and equilibrium constants. The value of the Gibbs free energy tells us whether a reaction will be spontaneous or not. Here we have the Gibbs free energy value of minus 12.5 kilojoules per mole. This value is negative, which tells us that phosphocreatine is broken down into creatine, and this is a spontaneous reaction. The forward reaction of creatine to phosphocreatine is favored. To calculate the equilibrium constant, we use the equation delta G equals minus R times T times natural log of the equilibrium constant, where R is our gas constant. Plugging in the values from before, we have KEQ equals 0.99547. The equilibrium constant is a measure of an equilibrium reaction to determine which way the reaction lies. Here we are calculating the entropy. We use the equation delta G equals delta H minus T times the change in entropy. and we have the value 0.156 kilojoules per mole. This tells us that the muscles have 0.156 kilojoules per mole of useful energy.
So now we're going to look at the uptake of creatine and phosphocreatine into muscle fiber via diffusion. Currently, it's understood that humans produce between 1 and 2 grams of creatine per day in the liver, kidneys, and pancreas, as we previously discussed. The supplements, creatine supplements, are dosed between, there's a loading phase for 2 days of about between 12 and 15 grams of creatine per day, followed by 5 grams of creatine per day before workouts. So now we're going to talk a little bit about how creatine moves from the bloodstream into the muscle fiber. So we assumed Fick's first law, which states that the change in concentration, in this case of creatine and phosphocreatine, with respect to the change in time is equal to the negative diffusivity of creatine or phosphocreatine in our case, times the change in concentration with respect to distance. Fick's first law is essentially stating that the change in concentration, the motion of the molecule, if you will, from the bloodstream to the muscle fiber is dependent on time, position, or distance it has to travel, as well as diffusivity, which is dependent on the structure and shape of the molecule that's trying to be diffused. We can simplify this model to something that looks more like this, where the flux, or the motion and movement of creatine and phosphocreatine, is equal to the negative permeability, in this case the permeability of the muscle fiber to creatine, times the surface area of the muscle fiber, times the change in concentration. Fick's first law is based on the idea that the driving force for diffusion is the change in concentration expressed in this equation. Even though this is a nice simple equation and should be easy to compute, it's very difficult to calculate this for everybody, since changes in height, weight, gender, muscle composition, permeability of muscle composition due to changes in ethnicity or history all make it very difficult to calculate this for everyone and make a generalized statement as far as the uptake of creatine and phosphocreatine in the muscle fibers.
As you can see, the reaction of creatine in the body is essentially a two-way reaction. On one side you have creatine and ATP, which the process or the reaction is catalyzed by the creatine kinase into phosphocreatine and ADP. This process works both ways. As you can see, this is essentially a table of the mass balance of creatine. So the molar ratio of ATP, creatine, ADP, and phosphocreatine is essentially a 1:1:1:1 ratio. Naturally in your body, you essentially have 1 gram of creatine produced daily, which amounts to 3.8676 grams of ATP. Now in comparison to what bodybuilders take in daily, they essentially take 2 or 5 grams a day, which would produce either 7.74 grams of ATP or 19.34. And comparing it to the natural occurrence in the body, it is either essentially more than doubled or more than 6 times more production of ATP.
I did see results as far as when it comes to putting on mass and having energy during the workout.
Yeah, I mean, mine's basically the same thing. I used creatine probably a couple years ago. I don't really remember what it was. Yeah, it helps put on mass.
Hi, my name is Amelia, and I will be talking to you about the potential medical benefits and side effects of creatine. Creatine kinase is analyzed in blood tests as a marker for severe muscle breakdown, heart attacks, muscular dystrophy, autoimmune responses, and acute renal failure. Cardiologists look into this to see how severe someone's heart attack was to determine how bad the muscle damage is. Geriatric patients happen to have silent heart attacks where they don't even feel that they have a heart attack. So when they come in to see a doctor, this is an indicator that can be used to determine how severe the heart attack was. Essentially, research shows that creatine may be able to help those suffering neuro and muscular degenerative diseases. Essentially, it is helpful in reducing fatigue in those conditions and increasing strength in such illnesses where muscle weakness occurs, including COPD, congestive heart failure, Huntington's disease, any mitochondrial illnesses, and especially muscular dystrophy. Dosing essentially for muscular dystrophy is about 5 grams for children or per day, or 100 milligrams per kilogram of body weight. There is, as I mentioned, these are the potential benefits of creatine, but the side effects, you could say, aren't as bad, but should be put out there as well. So creatine is metabolized by the kidneys, and the fear is that the usage may cause kidney injuries. But however, if you begin supplementation with healthy kidneys or with safe and non-excessive doses, there should not be any kidney concerns.
Creatine, I feel like, you don't really need the boost creatine to work out. You just gotta get motivated to actually like hit the gym, hit the weights. But personally, I don't think so.
I would just have to say it's just personal views, like what you're really trying to do in the gym. You know, if you're trying to get as big as you possibly can get and put on as much weight, then I'd say it's worth it. But if you're looking for the energy boost,